In this problem, I've got Eudora running home to her secret laboratory, and there's two different speeds. She goes part of the way at a slow speed, that's when she's running, and then she gets on her jetpack to get to her secret laboratory faster, and she goes at 76 kilometers per hour. There's two equations that I can write. That's why this is a system. One equation is for the total distance, and the other equation is for the total time. So before I start, I need to identify the variables, and I can look in the question for that. It says, how long did Eudora spend running, and how long did she spend flying? So that means the two unknowns, the two things that I'm trying to solve for, are R for running, and I'm going to use J for jetpack instead of F for flying. So I've got two equations. The green equation is the total distance. That's going to involve the speeds. The yellow equation, the whole trip took 2 hours. I can just add my two times. This is the running time, and that's the jetpack time. So the first equation I know is that the running time plus the jetpack time is equal to 2, because the entire trip was 2 hours. So entire means add those together. The second equation that I know is the total distance. 12 was for running, and 76 was for jetpack. So I need an equation that says 12 kilometers per running and 76 kilometers per hour jetpack. 12 kilometers per hour running plus 76 for the jetpack is equal to, and then she traveled, so this is the distance she traveled running, this is the distance she traveled jetpack, and the total is 120. So in this problem, I'm trying to find R and J that add up to 2, and they also have to satisfy this other condition. We have been solving this using the table method, but I'm actually going to go ahead and solve it using the elimination method. So I'm going to rewrite this equation after I multiply this top one by -12. And the reason for that is that I'm going to create a system where the top equation is going to eliminate or cancel with the bottom equation. So if I multiply everything in the top times -12, I get -12R, -12R, -12 times J, and then -12 times 2, so that's equal to -24. And the reason I did that is that now this will cancel with the bottom equation. I'm going to take the orange equation and write it down here. Alright, so now I have a system that does cancel. I can cancel the -12R with the +12R. That's called eliminates. I just eliminated the R's. And I'm going to combine everything that's left. So 76 minus 12 is 64 J's. And then 120 minus 24 is 96. My last step is to divide. I am going to get a decimal here, and that's not going to freak me out. So I've got 96 divided by 64. And that gives me 1.5 for jetpack. Alright, once I know jetpack, I can plug that back into the original equation. I know that jetpack plus running was equal to 2. So it must be jetpack plus running is equal to 2. And if jetpack is 1.5, then R must be 0.5. So the solution to question number 1 was R equals 0.5 for running, and jetpack was 1.5. Let me summarize that as a sentence. Because the last step, first step, define your variables. Last step is always to summarize it as a sentence. Eudora spent 0.5 hours running and 1.5 hours on her jetpack. Please complete the question that says describe how you solved this. And in the description, I would like you to make sure the beginning of the problem is to define your variables, and we use the elimination method here for a system of equations. And then the final answer was half an hour running and 1.5 hours on a jetpack.